Okay, so now we're going to find some missing values given the variation equation. So a lot of the times we're going to have to find that equation first and then use it to find some missing numbers. But there's different ways that you can do this. There's a lot of different ways that you can do this. And with enough practice, you just kind of start seeing what that number is supposed to be. It kind of starts becoming natural whether you're going to multiply or divide. You do need practice with this, but after writing down enough times, you start seeing the patterns. So these examples are only showing ones where we're told what type of variation it is, and then you're given one of the points and you have to find a missing part of it. But that doesn't need to be true. You could be given a table, like in the last video I showed you where you have a table. You could be given the table where 3 of the points are filled in, and the 4th one is missing a coordinate, and you have to find that 4th one. If you know the type of variation, and you know part of the coordinates, you should be able to figure out what is that missing coordinate. So we are going to find the constant, and what it means to be constant is that it is equal between all ordered pairs for that variation, for that set. The constant must be the same. So we're told here that these x and y vary directly, and that's our x and y combination. For direct variation, I know I'm using k equals y over x. So to find my constant, I'm going to do 4 divided by 2, which is 2. In the same variation, that should also remain true, which it does, because 32 divided by 16 is also 2. So actually, I didn't need to know that this was 32. Let's say I wasn't told that, and it said y equals something. I should be able to figure that out. If I know the constant already, I know that y divided by x gives me 2. I should be able to figure out some number divided by 16 gives me 2. That's an equation that you can solve. So there's a couple different ways to do this. Actually, this is one way where you set the constant equation variations equal to each other. So the two constant variations equal. And then you solve for the missing variable. This is actually not how I naturally do it. Naturally, once you get some practice with this, you just start thinking about what is the k between those numbers that you're given. So for a direct or inverse variation, you start seeing the k right away, because it's really not that hard to find. You just divide y by x, or you just multiply y by x. So you start thinking about it quicker than having to set up this whole proportion or equation with a missing variable. You start seeing it right away, and then you just plug it into the other equation with the x or y that you're given. I'm going to actually show it both ways. So this one we're told that they vary directly. The first thing I would do is just write down the tools that you have. If you know that they vary directly, you know that, and you know that. You know those two things, that y equals kx, and also that k is y over x. So the steps at the top basically say that we're going to use that bottom equation for both of these points, for this one and for this one. This is 48 over 12. This is 6 over something, some x value that I don't know yet. But I know the constants have to be the same. I know that k is the same for both of these. So I'm going to combine those two equations and write it as 48 over 12 equals 6 over x. That's a proportion that we know how to solve. You should have seen that a bunch last year, where you cross multiply. You get 48x equals 72. And then we divide by that 48 to actually solve for x, which really just tells us that x is 1.5. Honestly, that seems like a lot of steps to me, especially after seeing what I know I'm supposed to get. So really, I'm going to rewrite this whole problem and solve it a different way. I'm going to leave this part because that's going to be useful to actually find the constant for this equation. I know that my constant here is 4. And I know at least 2 parts of that equation. I know a y value. I don't know the x, but I know the k. I know that in this equation, I can put 6 here, I can put 4 there, and I just have to solve for x. That looks way simpler to me than cross-multiplying and then solving actually a similar equation where you have to divide away this 4. And that still gives me that x is 1.5. I just think of that more naturally. Really, whatever you want to do is kind of up to you. As long as you're just thinking about these 2 equations that you have at your disposal. You can use either of them. You can use a combination of the 2. But it's really up to you and how you think about it. I'm going to do the other direct variation one just so you can kind of see that pattern. And I'm actually just going to do it. No, I'll do it both ways. Okay, so we know that they vary directly. So we know that k is y over x. So k is 9 over negative 3. And k is negative 21 over some x value. Okay, so I'm going to set those 2. I'm really going to combine those 2 equations. I'm going to set those 2 equal to each other. 9 over negative 3 equals negative 21 over x. Honestly, I wouldn't be surprised if you already see the x value that has to go in there. This is another natural way to think about it. I'm thinking about going from this to that. What's happening? So going from negative 3, it's supposed to be negative 3. Going from negative 3 up to 9, I'm multiplying by negative 3. So going from something up to negative 21, I can almost just guess and figure out what that number is. I'm going to solve this the right way. I'm going to use a proportion, so I'm going to cross multiply 9 times x, and cross multiply again. That's 63. That's negative 3 times negative 21. And then I divide away that 9. And so x is 7. And again, you can always check this using your original equation here. That and that, they have to be the same. 9 divided by negative 3, that's negative 3. And negative 21 divided by 7 is also negative 3. I'm just going to recap what I did in that first problem. I'm going to just solve this in the way that I just think about more naturally. I'm going to divide 9 by negative 3 and find that my k is actually negative 3. Then I'm going to take this value and take that value and write them into this equation. Negative 21 equals negative 3x, which means I'm really just dividing by negative 3 on both sides, and x is, again, 7. Alright, now example 2 and 4, they vary inversely, which means these are the 2 tools that I can use. Oops, I'm going to write that same exact equation again. Those are my 2 tools. This one is actually way more intuitive to use the steps above. Actually, I'm just going to use that every time. Because if I know that it's inverse, I know that I'm multiplying I'm multiplying y times x to give me k. So I know I'm multiplying 8 times negative 4 and 16 times some y value, and I'm going to get the same number. So I can actually put these two together. I'm going to simplify this a little bit first, negative 32. And this I'm just going to rewrite as 16y. This one's very simple to solve because those actually have to be the same. Those are equal to the same k value. So negative 32 equals 16y. If you divide by 16 on both sides, you find out that y is negative 2. Again, you can check this just using those original equations. You know you need to get the same number each time you multiply your combination of x and y. Negative 4 times 8 and negative 2 times 16 give you negative 32. They give you the same constant. X and y again, very inversely. That tells you which equations we can use. I'm going to use that constant equation again. K equals yx, so k equals 6 times 7, and k equals 3 times some x, so k equals 42 on this one. K is also going to be 42 on this one. 42 equals 3x, and then you divide away that 3 to find that x is 14.